At Coactive Science, we build artificial intelligence for the natural world. Today, we want to talk about the ocean, the most productive resource on the planet, and why the people who depend on it are still flying blind. The coastal ocean feeds billions, stores carbon, and powers entire economies. It's the most valuable resource we have and the hardest to see clearly, and it's changing faster than we can track. Harmful algal blooms, low oxygen events, invasive species, falling water quality. Every one of them destroys productivity. Lost harvests, closed fisheries, degraded water. And the data we use to manage them still arrives in snapshots, months apart. The hard part was never the phenomenon, it's the monitoring gap. Optical satellites have a cloud problem, a cadence problem, and a spectral problem. One cloudy season, and the picture goes dark for months. Take aquaculture. It already produces about half the seafood we eat, and it's the fastest growing food sector on Earth. But a single bloom or low oxygen event can wipe out an entire harvest overnight, because the operator never saw it coming. That's what changes when you can finally see the water. Our Orbit to Onsite platform gives farmers days of early warning, maps conditions across every pond, and turns reactive losses into steady, higher yield, grown sustainably. And the same intelligence protects everything else the ocean provides: fisheries, drinking water, wetlands, and the carbon stored in seagrass and mangroves, by catching threats while there's still time to act. Coactive Science builds geospatial foundation models for the natural world. Our thesis is simple. There is no internet-scale dataset for a living coastline, so the model that wins is the one that decides what to measure next. We've productized that into one continuous loop, from orbit to on-site. Stage 1, detect. We fuse multispectral, hyperspectral, and radar satellite data and run AI segmentation that separates a real signal from harmless noise. Stage 2, forecast. We combine detection with currents, wind, and biology to predict where a bloom or an invasion will spread and when it will arrive. Stage 3, validate. With Pacific Northwest National Laboratory, we pair Raman and other in-situ sensors for more accurate on-site measurement, confirming the toxins, the oxygen, and the nutrients actually in the water. Satellites tell you where, the ground truth tells you what's really there. Stage 4, decide. An agentic AI layer watches continuously, updates its forecasts in real time, and turns all of it into a clear on-site recommendation, escalating to a person only when it matters. Detection alone is a research output. The full loop is an operation service. We don't sell a map. We sell the decision that protects a harvest or a habitat. And it's real today. Our platform monitors more than 160 sites, aquaculture farms, coastal habitats, invasive species hotspots, and water quality stations, each one updated as new observations come in. Here's a live example. The system detects a sargassum bloom off Puerto Rico, forecasts its drift toward the southern coast, and issues an alert days ahead. And just as importantly, it stays silent when a bloom drifts harmlessly out to sea. The same loop drives value across the board. Higher, more predictable yield for aquaculture, early warning for coastal towns and water authorities, invasive species detection for agencies, and habitat and blue carbon verification for the organizations that manage them. It even watches the water around industry, tracking acid drainage and runoff at and downstream of mining sites, so contamination is caught early, not after it reaches a river. This is AI for science, and for the economy that depends on healthy water. If you run a farm, a city, an agency, or a conservation program, we'd love to build it with you. Coactive Science, intelligence for the productive living ocean.